Good morning. This is your Stat Sensei, Mr. Spensei, and this will be Introduction to the Binomial. And we're going to be running the PDF. So we'll be looking for a singular value and we'll be working with the binomial. We'll be working with the recipe in your note spiral. So this is a scenario one about light bulbs. Suppose that the probability of having a defective item is 0.3. So they're telling us a probability right here is 0.3. That's kind of important. And we're going to assume that it doesn't change. Given a box of 5 light bulbs, well, that means I have a group or a sample of 5 light bulbs. All right. Then it says, what is the probability of having 0 defective light bulbs? Well, this would be my success in this case would be having 0 light bulbs. So let's take a look at our recipe real quickly. First off, is this in fact a binomial? Well, we have two outcomes. We could have a defective or a non-defective, so that's good. Probability of drawing a defective is 0.3. There's no reason for it to change. All right, so that takes care of independent trials. Same chance of success is always 0.3. And we have a box of 5 light bulbs, which means I could have 0 defects, 1 defect, 2 defect, 3 defect, 4 defects, or 5 defects. So I could have 0, so I start at 0, so that's the O part or the 0 part. And the number of trials is set. We already said that we have 5 light bulbs. That's our group size. Okay, so it looks like a binomial. First thing we need to do is name the distribution and define X. Well, this is the binomial. And by the way, I'm only going to define it for the first one on this problem because all of them are going to be binomial and it's all going to be X. Let X equal the number of defective light bulbs. I'm just going to write defective lights to abbreviate. All right, the next thing is draw the graph. Well, I already made a number line. I can have 0 defects, 1 defect, 2 defect, 3 defect, 4 defects, or 5 defects, and circle the number of desired successes. Oh, in this case, I only want 0 defects, so I'm going to circle 0. That's what I need. I need to identify my p-value. My p-value is 0.3 and n is 5, so that's done. The next thing I need to do is go, okay, let's look. Because when I look at my recipe, I have choices. Did I circle one value or 2 or more? If it's 2 or more, I'm going to go down the right-hand side, but I only circled 1 because I only circled the number 0. And it says, all right, write the probability statement in symbols. Well, in this case, our probability statement is we're looking for the probability of X, the number of defective light bulbs, equals 0. Probability of X equals Z. The P is just for probability. All right. The next thing, write the formula. N choose X. N choose X. Then it's P to the X. And then 1 minus P to the N minus X. Well, N is the number of trials. And we said we had 5 trials. How many successes? I want 0. Our probability of success was 0.3. So 0.3 to the 0 times 1 minus P. And this is going to be 5 minus 0, which in this case is just 5. Okay, so we've now plugged into the formula. We've done through the first 7 steps, and we're on to the calculator. So we're going to go second, vars, and we're going to drop down to binomial PDF, which is at letter A, and press enter. Trials, well, we had 5. That was our N. Our p-value was 0.3. X is our number of successes, which is 0. And we press enter, and we end up with 0.16807. So that's our answer, 0.16807. All right, I'm going to shortcut these next ones by a fair amount. I'm not going to do all the steps because it's the same problem. But what is the probability of having 1 defective item? Okay, so my number line is 0, 1, 2, 3, 4, 5, because we had a box of 5. and we could have one defective item. Our p-value, our probability of success is 0.3, or the probability of a defective is 0.3, and our group size happens to be 5, so we need that. And I'm going to go ahead, since I've already written the formula, I'm not going to do that again, but I do need to write my probability statement. My probability statement is the probability that x equals 1. In this case, we're going to go, all right, plugging in 5, choose 1, 0.3 to the first power, and 1 minus, I should have put a 0.3 here, 1 minus 0.3, and 5 minus 1 is 4. So that 4 came from 5 minus 1 because that's the formula, n minus x, this minus that. All right, so we're going to go back to our calculator, second vars, binomial PDF, trials is 5, p is 0.3, x value I'm changing to 1, boom, 0.36105. Oh, 0.36015. I wrote that wrong. Let me rewrite that. 0.36015 and box that in. And I'm taking these all the way out because at the very end, I'm going to need that information. So what's the probability of having two defective items? Well, once again, my number line is 0, 1, 2, 3, 4, 5. My probability of a defective is 0.3. The number of trials or my group size is 5. And I'm interested in 2. So our probability statement is the probability that x equals 2. So our equation is going to be 5 choose 2, 0.3 to the second power, 1 minus 0.3, that's the probability of failure. And what's 5 minus 2? 5 minus 2 is 3, and that goes there. So when we go to run this thing, we go second vars, binomial, PDF, trials is 5, probability is 0.3, but our x value is now 2, and we end up getting 0.3087. So the next one, what's the probability of having 3 defective items? Well, our number line is 0, 1, 2, 3, 4, 5. We want 3 defective, so we're going to circle that. The probability equals 0.3, n equals 5. So we want our probability statement is the probability that x equals 3. In this case, we have 5 choose 3, 0.3 to the third power, 1 minus 0.3, and 5 minus 3 is 2. So second vars, binomial, PDF, which is letter A, trials is 5, probability is 0.3, our x value is 3, and we end up getting 0.1323. All right, continuing on, what's the probability of having 4 defective items? 0, 1, 2, 3, 4, 5. Probability is 0.3, n is 5. So the probability that x equals 4 is our probability statement. 5 choose 4, 0.3 to the fourth power, 1 minus 0.3. 5 minus 4 is just plain old 1. So second vars, binomial PDF, change 5 trials or a group of 5, a probability is 0.3, and our x value is going to have to be changed to 4. And we get 0.02835. So that's the probability of having 4 defective items, 0.02835. And the last one, what's the probability of having 5 defective items? Well, once again, 0, 1, 2, 3, 4, 5. We're circling a single value. Our probability is 0.3, n is 5, and the probability of x equaling 5 would be 5, choose 5, 0.3 to the fifth power, 1 minus 0.3. What's 5 minus 5? Oh, that's 0, so this is 0. Second vars, binomial PDF. And we just changed 5 trials, probability is 0.3, our x value is 5. But we end up getting 0.00243. So the probability that all 5 are defective is 0.00243. Okay, next thing it asks, what is the sum of all the probabilities? So I'm going to start adding these up. So I need to start off with this first one. The probability 0.1687, 0.16807. All right. Probability the second, then add the second one, 0.3601, 015, plus the next one, 0.3087, plus 0.1323, plus 0.02835, plus, and our last one, 0.00243. And I sure hope I input those right. And I did because the sum's to 1. So the sum is 1 because this is a valid probability distribution. Now, there's actually a place on the calculator where we could do something to show that, but for the time being, we can just say, hey, the sum of all those things equals 1. Valid probability distribution. Pretty cool. So what is the sum of the probabilities of questions 1 through 5, which means no more than 4 defects? All right. So in this case, we're leaving off the probability of 0. So we're going to skip this one. I don't think this is one I want to deal with on this video because it's a different problem. Because in this case, we go 0, 1, 2, 3, 4, 5. No more than 4 defects means I could be looking for these values, and that will be handled in the next video. And because we're not going to be looking at the one value, we're looking at 2 or more values. So be careful if you're circling more than one value, you're going to have to use the other column. Also, our probability statement would be different. Our probability would be probability that x is less than or equal to 4. Okay? So going back, this says how many would you expect? Oh, the expected value formula. The expected value formula for the binomial is n times p. Well, we know n was 5. We know our probability was 0.3. So it's going to be 5 times 0.3, which gives us 1.5. So our expected value, the number we would expect if we did this over and over again in the long run, would be 1.5. The next thing it asks for is our standard deviation. Well, the standard deviation for this is the square root of n times p times 1 minus p. So in this case, that would equal the square root of 5, that's our sample size, times 0.3 times 1 minus 0.3. And when I go to the calculator, 5 times 0.3, 5 times 0.3 times 0.7, that's 1 minus 3. And I get that number, and then I have to raise it. I have to raise it to the half power, raised to the 0.5, and I get 1.0246. And I just like to truncate, equals 1.0246. All right, appreciate you watching, and I sure hope to see you on the next one. Thank you.